Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't done it yet. Now again we are going to solve the same particular problem which we have solved already in the previous video using the vector method. Now we are going to solve this problem using the graphical method, and this is the problem related to the relative motion between any two particles or between any two bodies. So now in the problem statement says that at the instant shown in figure 1245a, cars A and B are traveling with speeds of 18 meter per second and 12 meter per second respectively. Also at this instant A has decreased in speed and B has increased in speed of 3 meter per second square. Determine the velocity and acceleration of B with respect to A. So first of all we have to focus on the velocity. So we are required to find the velocity of car B with respect to A. So this is required. We have to find the magnitude of the relative velocity of car B with A. So now as we know that VB A, this is equal to VB vector minus VA vector, or we can say that VA plus VBA is equal to VB. And remember that both of these equations, these are the vectors, right? This is the vector subtraction, or we can say that this is the vector addition. So we can modify this equation, since in case of the subtraction in vectors, we need to reverse the direction of that particular vector which we want to subtract. So we can write this particular equation is VB vector plus the negative of VA. So when we reverse the direction of the velocity vector of car A, and then we need to add that vector with VB, so we will get, by head to tail rule, we will get the velocity of car B relative to A. So we need to apply the graphical method. So let me write that. So for graphical method, we need to define our scale. So for scale, since in the problem statement it is said that the car B has a velocity of 12 meters per second in the downward direction, that is in the negative y. This is the fixed reference frame and this is the translating reference frame. The translating reference frame is attached with car A, since we want to find the velocity of car B relative to A. So that is why we have this x dash and y dash axis attached to car A. So the velocities are given, and the velocity of car A is 18 meter per second, making 60 degrees, and the velocity of car B is 12 meter per second, and it is acting in the downward direction. So now let's say that 1 centimeter, or we can say that 2 meter per second is equal to 1 centimeter. So similarly, we can say that if the velocity of car A is 18 meter per second, so 18 meter per second is equal to 9 centimeter, and this 12 meter per second is equal to 6 centimeters. So now by head to tail rule, we have to apply this equation by head to tail rule. We have to subtract VA vector from VB by head to tail rule. So we have to draw VB. VB is in the downward direction. It has a magnitude of 12 meters, but according to our scale, 12 meter per second is 6 centimeters. So we have to draw a 6 centimeter line in the vertical direction. So now let's draw that 6 centimeter line. So this is our 0, somewhere here is our 0, and somewhere here will be our 6 centimeter line. Let me write here. So this is our 6 centimeter line, approximately, right? This is 6 centimeter. So this will be the 6 centimeter is, this is the 6 centimeter is VB. Let me write that this is VB. And this is VA. And similarly, the VA is 18 meter per second, and it is making 60 degree with the horizontal. So we need to draw a line of 9 centimeter at an angle of 60 degree. So 9 centimeter at an angle of 60 degrees. So first of all, we have to set the 60 degrees and then we have to draw the 9 centimeter line. Okay, first let me move this line and then we have to draw the 9 centimeter line from the 0. So from here to here, let's say this is my 9 centimeter line, let's say. So now this is my VB equals to 12 meter per second. This is my VA, but this is, since VA is acting in the downward direction, but since we need to subtract it by head to tail rule, we need to subtract VA. So in order to subtract it, we need to reverse the direction of VA. So VA is actually acting in the downward direction, so we need to reverse. So this is the reverse direction. So this is actually minus VA vector. And its magnitude is, let me write that the magnitude is 18 meter per second. So by head to tail rule, the resultant will be from the tail of VB to the head of minus VA. So this will be our resultant vector. Let me draw just a simple straight line. This will be our VA, VB relative to A. This is VB relative to A. And now if I take that ruler and if I measure the length of this VBA, so that will be the direct solution. That will be the magnitude of the relative velocity of curve B relative to A. So this is my 0. And this is approximately 4.8, right? 4.8. So VBA length is, let me write that VBA length is approximately 4.8 centimeter. And since 1 centimeter is equal to 2 meter per second, so we need to multiply it in order to get the magnitude in meter per second. So this is 2 into 8 is 16 and 2, this is 9.6 meter per second. So this is the solution. This is the magnitude of VBA using the graphical method, and we can find the angle. If we measure the angle with the help of the protractor, so that will give us the angle, and this angle is, from here we can say that this angle is, this particular angle at the middle of this ruler is 23 approximately. So this angle is approximately 23. So this angle, the angle of this VBA with the horizontal is, now we come up to this solution using this particular equation by subtracting VA vector from VB. So this is VB minus VA. We will get this as the resultant by head to tail rule. Now we can use this equation as well. So according to this equation, VA plus VBA will be equal to VB. So this equation can solve our problem very easily. We do not need to reverse the direction of any vector, since VA plus VBA is equal to VB. So now if I draw VA, this is our VA vector, this one. This is our VA vector, and this VA vector, we have reversed this VA vector. But if I copy this VA vector, let me copy it, and if I paste it, so this is that VA line having that same length, but now I am going to place it here. I am going to place it here on the tail of VB. And now I'm not going to reverse the direction. I'm going to place the arrow here, which is the actual direction of this VA. VA is acting in this downward direction. So now I'm not going to reverse the direction. This is that same direction of VA, and the magnitude is 18 meter per second. And now this vector is VB, this is VB, this is VA. So now according to this equation, this VA plus VBA, so VBA needs to be from the head of VA until B. And here we have VB, and this is minus VA. So now if I copy this resultant, which is VBA, and if I place it here, we will get that same length. And this time, this will be from in this direction, right? This is VB, this is VA, and this is VBA vector. Now it's up to you. Both will give us the same answer, since both of these equations, they are same equations. So this is now VA plus VBA is equal to VB. And this is, according to this equation, this is VB, this is minus VA. We need to reverse the direction of VA, and then from the tail of VB to the head of VA, that is the resultant. And similarly, if we draw these velocity vectors without changing the direction, and if we join the tails of both of these, again, let me draw it here just to simplify. So this is VB vector, and this will be our VA vector, and we just need to join their tails, right? So VA, VB, and then we want to find the velocity of B relative to A. So we need to draw a vector starting from A, and that will end at B. So we will have the resultant like this. This will be the resultant. So this is VBA. So this is the easiest method. Do not alter the direction of the given velocities. Just join them at their tails. And then if you want to find the velocity of B relative to A, start a vector from the head of A and end it on the head of B. And if you are required to find the velocity of A relative to B, so we have to start a vector from the head of B, and that will end on the head of A if you want to find VA of B. So again, we have that same VBA length, we will have that same answer, and that will be 9.6 meters per second. And if we measure the angle of this VBA, we will have that same angle of 23 degrees. Now again, if we want to find, this is the solution by using the graphical method. Now we can find the solution by using the sines and cosines law. So now if you want to find this VBA magnitude, or this VB magnitude using the cosines law, so now if I draw a horizontal line here, let's say, if I draw a horizontal line here, so this VA vector, this is making 60 degrees. So we can say that this is 60 degrees, and this VB vector, this is vertical, so this is 90 degrees. So 90 minus 60, this angle is 30. So let me write that this angle is 30. Similarly, if I draw a horizontal line here, let's say, so again, this is that VA vector, it is making 60 degrees. This is vertical, this is 90. So 90 minus this 60, this is 30. So this angle is also 30. This is 30. And if we look into this diagram, so this line and this line, they are parallel to each other. So if they are parallel to each other, so this angle and this angle, they are alternate angles. So this must be equal 30 and 30. So now we know the angle between this vector and this vector, or we know the angle between this vector and this vector. So we can find this magnitude by using the cosines law. So now if I apply the cosines law, so by using the cosines law, we can say that VBA magnitude square is equal to VA square plus VB square minus 2 into VA VB cos of the included angle between this VA and VB. So the included angle is 30, so cos of 30. And now if we want to find VBA magnitude, so we need to take the square root on both sides of the equation. So now VA is 18, VB is 12, minus 2 into 18 into 12 cos of 30 under the square root. So this is 18 square plus 12 square minus 2 into 18 into 12 cos of 30. This gives us the magnitude of VBA equals to 9.689 meter per second, which is approximately equal to this 9.6 meter per second. Since the ruler can measure the length up to 1 decimal place, that is up to 1 millimeter, so we will get the answer is 9.6 meter per second using the ruler. But using the calculator we can find the answer more accurately. So the velocity of B relative to A magnitude is 9.689 meter per second, and now we have to find the angle of this VBA. So we have to find this angle. We have to find the angle of this VBA, this angle theta. We have determined this, but that VBA will make that same angle theta here as well. So we will have that same angle theta here as well. And if you want to find the same angle theta, so let's say that we find this particular angle. Let's say that this angle is beta. So using the sines law, we can find this angle beta. So if I apply sines law, we can write that sine of beta divided by the magnitude of the opposite side. So the magnitude of the opposite side is 12. So divided by 12 equals to sine of 30 divided by the magnitude of the opposite side. The opposite side is this VBA, which is 9.689. So divided by 9.689. And if you multiply both sides of equation by 12, 12 will cancel out. We will have sine of beta equal to that. And then beta is equal to sine inverse and sine of 30 into 12 divided by 9.689. This will give us that beta angle. So sine inverse sine of 30 into 12 divided by 9.689. This gives us beta equals to 38.262 degrees. So this is that beta. Now we know that this whole angle, this is 60. Since VA is making 60-degree angle, so this total angle is 60. This total angle is 60. So 60 minus beta will be theta. So we can say that theta is 60 minus beta. So 60 minus beta, which is 38.262, this is equal to 60 minus 38.262. This is equal to 21.738. So 21.738 degrees. So the angle is also approximately equal to this angle. We will most probably use these cosines law and sines law, but we need to know how to implement these equations. So this is how we can find the velocities using the graphical method. For the acceleration, we can find the acceleration using the same graphical method. So for that is we know that this car B is moving in a circular track. Let's say the car B is moving in a circular track, so it will have the normal acceleration towards the center, and it will have the tangential acceleration. So the tangential acceleration is given. So first of all, we have to find the resultant of this normal acceleration of car B and the tangential acceleration of this car B. So as we know that the normal acceleration of car B will be equal to VB square divided by rho. Now VB is known. The velocity of car B, which is 12 meters per second at this particular instant. So that is 12 square divided by 100, the radius of curvature. So that is 1.44. 12 square divided by 100. This is 1.44. So 1.44 meter per second. And similarly, the tangential component, the acceleration of B in the tangential direction. So that is the tangent to the curvature is this 3 meter per second square. So this is 3 meter per second square. And if I draw it here. So this is ABN, and this is AB tangential. And if we add up both of these, this is ABN plus ABT. So this will be the resultant. So let me draw the resultant like this. This will be the acceleration of B at this particular instant. And it is going to make some angle, let's say phi. So we can find the magnitude of the AB. So the magnitude of AB will be equal to ABN square using the Pythagoras theorem. So this will be ABT square under the square root. So let's find this. ABN is 1.44 square plus ABT is 3 square. This gives us 3.3277. So it is approximately 3.328. This is 3.328 meter per second square. And this is ABN, and this is ABT, and this is the resultant. So this is that angle phi. We can find this angle phi by applying tan phi. So tan phi is this AB tangential divided by this. AB tangential is this 3 divided by 1.44, and from this we can say that phi is tan inverse 3 divided by 1.44. So tan inverse 3 divided by 1.44, this gives us 64.359. 64.359 degrees. So now we know that the acceleration of B is acting in this direction, and it is making 64.359 degrees with the horizontal. And this is that particular angle like this. This is that angle phi. And we know that the acceleration of car A is 2 meters per second, and it is making 60 degrees. So now we are not going to solve it by the graphical method. We will draw the diagram not up to the scale, but we will use the sines law and the cosines law for find the acceleration of B relative to A. So now again I will use that same method. I will use this equation for the acceleration. Again we can write that the acceleration of B relative to A, this is equal to acceleration of B vector minus the acceleration of A. If you do not remember this equation, so convert this slash to minus. So AB minus AA. And now we can say that AA, if I bring this AA to this side of equation, so this will be AA plus ABA, this is equal to AB. Now we are going to use this equation for head to tail rule. So AA, this is AA. AA is in the upward direction. We do not, for this equation, we do not need to reverse the direction. So AA is making 60 degrees, and it has a magnitude of 2 meters per second. So let's see, this is AA, 2 meters per second square, it is making 60 degrees. And then AB. Now AB is acting in the downward direction, right? This is AB. And using this equation, we need to join their tails, right? This is AA, and we now need to draw that AB somewhere here. But this AB is making angle 64 degrees. So now let me draw a horizontal line here. Now if I extend the line of action of this AA, so this angle will be 60. But that AB is making 64.359 degrees. So from this we can say that AB vector will be somewhere like this. That will be greater than this angle, right? Let me extend the line of action of this AA like this. So this is the line of action of this AA. This angle is 60. But from here, from this calculation, we know that this AB is making 64.359 degrees in this direction. So we can say that 64.359 359 will be somewhere here like this. So this will be 64 approximately. So now this will be our AB, and AB magnitude is 3.328. Like this, let's say. So now this angle is 64.359 degrees, and this is AB, and AB magnitude is 3.328 meter per second square. Now again, look into this. This is AA plus ABA. So now we need to draw a vector from which will start from the head of A and which will end on the head of B. So we need to add ABA vector with AA by head to tail rule. So AA, then this will be ABA from the head of this AA to the head of this AB. So this will be the acceleration of B relative to A. Let me make it a bit larger, right? So let's make it a bit larger. This is the diagram, not up to the scale. So this is our diagram. And now we want to find this ABA magnitude using the cosines law. So now we know this angle, the angle between AA and AB. So how we know this angle? If this AB is making 64.359 with this, so we know this angle. This angle will be 180 minus this. So let me find that 180 minus 64.359. This gives me 115.641. So this angle is 115.641. Let's say that this angle is 115.641. Now the angle between this AA vector and this AB vector will be 115.641 plus 60 degrees. So this answer plus 60. So this is 175.641. So this angle is this angle is 175.641. So now let's erase all the angles. Let me erase all these. Now we know that this is 175. This angle is 175.641 degrees. Now we can find the magnitude of this ABA using the cosines law. So the acceleration of B relative to A magnitude square will be equal to AA square plus AB square minus 2AA into AB. Cos of the included angle is 175.641 degrees. And if we take the square root on both sides, so we will get ABA magnitude. This is equal to, now AA is 2, AB is 3.328 square minus 2 into 2, 3.328 cos of 175.641. So this is 2 square plus 3.328 square minus 2 into 2 into 3.328 cos of 175.641. This gives me the magnitude equals to 5.532. 5.324. This is 5 meter per second square. So now we know this magnitude. This is 5.324 meter per second square. Now we want to find the angle of this ABA with the horizontal. Now we want to find this angle. We want to find this angle of ABA with the horizontal, this particular angle. So now let's say that this angle is gamma. Let's say we want to find this gamma. So now to find this gamma angle, we need to find this angle, we need to find this particular angle. We need to have this angle. So now let's say that this angle is angle alpha, let's say. So now we can find this angle alpha using the cosine, using the sines law. So we can write that sine of alpha divided by the magnitude of the opposite side. So the opposite side is this AB. So divided by 3.328, and the sine of this angle equals to the sine of 175.641 divided by the magnitude of the opposite side, which is 5.324, or we can say that alpha is equal to sine inverse 3.328 sine of 175.641 divided by 5.324. So sine inverse 3.328 sine of 175.641 divided by 5.324. So this gives us alpha equals to 2.723 degrees. Now the gamma angle is this is the gamma angle, which is the angle of this ABA with this horizontal. So gamma will be equal to this, since this AA is making 60 degrees. So if this is 60, then this angle is 60. So gamma will be equal to 60 plus this alpha. So we can say that gamma angle 60 plus that alpha. So 60 and alpha is 2.723. So this is 62.723 degrees. So now the result is the acceleration magnitude of car B relative to A is 5.324 meter per second square, and it is making angle gamma, and gamma is equal to 62.723 degrees. And this angle is with the horizontal, and it is in this direction. So this is the solution of this particular example. I hope this will help you in your learning. Let me know in the comments if it helps in your learning. Like this video and subscribe Engineers Academy for the solution and practice of such more problems from Hibbeler dynamics.